Hi everyone, my name is Arunima, and me and my teammates Utkarsh and Philip are the MotorHeads, and this is our project of the dynamic headrest. Since cerebral palsy is one of the most common motor disabilities amongst children in the US, the impact on individuals diagnosed lose their independence on their posture and balance. So our need statement entails that wheelchair-bound patients diagnosed with CP at Matheny are constricted by their lack of angular range of motion in their head and neck region, thus restricting their field of view. Our goal is to improve patients' independence and quality of life by allowing them to manage the headrest position through an automatic control system. So in order to test parameters for a device, we have to meet certain customer requirements to provide optimal results for the patients. Our first goal is to deliver a proper control of lateral motion using a signal switch. This will be done by using an Arduino board with two simple commands of moving the headrest to the right and the left. Simplifying the design to 1 and 2 clicks to give two separate outputs makes it much easier for the patients to get their desired movement. And then having a uniform and smooth movement will be provided through the track of the headrest that can reduce the stiffness of the rotation, so we can ensure the safest way to allow individuals to turn their head without causing discomfort to their head or neck region. And lastly, our biggest requirement is to yield a proper range of motion of the headrest by setting a maximum and minimum degrees of rotation. So again, our patients can achieve their increased field of view.
Based on the customer requirements, we believe that smooth control of the device is the most important. Two main components tested are the single switch and linear actuators. Signal from the button will be interpreted by the Arduino computer and the output will be directed to the actuators. The output itself needs to be adjusted to make actuators perform needed actions based on the specifications of the design and patient's needs. The acceptable range of motion of the headrest is 60 to 80 degrees, where 30 degrees is our standard, which would allow for vision range to expand to 180 degrees. To ensure uniform, smooth motion, we're going to look at output voltage control and rotation speed of the headrest. We're going to do so by determining voltage values needed to control the actuator arm movement at specific rates. For signal generation, we're going to determine the time range it takes for a button press or presses to create an appropriate input.
So currently we haven't created an operational prototype, so we haven't obtained any concrete data just yet. However, based on the customer key requirements we talked about, we do anticipate to collect this data. More specifically, for the single switch, we hope to successfully integrate it so that 1 click moves it in one direction and 2 clicks moves it in the other. For rotation, we aim to achieve a 30 plus or minus 2 degree left and right rotation. And for speed, we hope to achieve a 1.25 centimeter per second or 7.5 degree per second speed. And our next steps include focusing more on the Arduino, ordering more of the supplies that we need, and beginning to work with the actual linear actuators. Thank you for listening to our presentation, and are there any questions?